Imagine you are standing on the deck of the fastest machine ever conceived by human hands. Behind you, an engine fueled by the annihilation of matter and antimatter hums with a power that could light up a continent. You press the throttle, the stars around you begin to shift, their colors bleeding from familiar whites into deep blues and violets. You are moving at 100,000 kilometers per second. You press harder, 200,000. The universe begins to look distorted, as if you are viewing reality through a thick, curved lens. You are approaching the ultimate threshold. You are chasing the ghost that has haunted physics for centuries. You want to reach 300,000 kilometers per second. But as you push the engines to their absolute limit, something terrifying happens. The more energy you pour into the engines, the less your speed increases. It feels as if the universe itself is thickening around you, turning into a cosmic molasses that refuses to let you pass. You aren't hitting a wall made of atoms or gas. You are hitting a wall made of pure logic. You are encountering the speed of causality. Why this number? Why 299,792,458 meters per second? Why can't we just go a little bit faster? Most people accept the speed of light as a cosmic speed limit simply because Einstein said so. But the why is much deeper than a simple rule. It is woven into the very fabric of how space and time are stitched together. If we could break this limit, the very concept of now would vanish, and the relationship between cause and effect would shatter into a billion pieces. Today, we are going to peel back the layers of reality to understand why this limit exists, how we discovered it, and why it is the only thing keeping the universe from falling into total, timeless chaos. For most of human history, we believed that light was instantaneous. If a fire was lit on a distant mountain, we assumed the light reached our eyes the exact moment it was created. Even the great thinkers like Aristotle and Descartes believed light had no speed because it was a transformation of space itself. But in 1676, a Danish astronomer named Ole Rømer noticed something strange while observing Jupiter's moon, Io. He realized that Io's eclipses happened later than predicted, when Earth was moving away from Jupiter, and earlier when Earth was moving closer. Rømer didn't blame the moon, he blamed the distance. He realized that light was a traveler. It had a journey to make. It was the first time humanity realized that light was not an event, but a physical thing moving through the void. Fast forward to the 19th century, and the mystery deepened. James Clerk Maxwell, perhaps the greatest theorist since Newton, formulated the laws of electromagnetism. His equations showed that light was an electromagnetic wave, and they predicted its speed with startling accuracy. But his equations also revealed something deeply troubling. They suggested that the speed of light was a fundamental constant of nature. It didn't matter how fast the source was moving or how fast the observer was moving, the speed of light always came out to the same number. This defied everything we knew about motion. If you throw a ball from a moving car, the ball's speed is its own speed plus the car's speed. That is common sense. But Maxwell's math said light didn't care about your car. It didn't care about your speed. It was always stubbornly 300,000 kilometers per second. This created a crisis in physics. Scientists tried to invent a substance called the luminiferous ether, an invisible medium that filled all of space, thinking light must be moving through it like sound moves through air. They thought if we could just find our speed relative to this ether, we could fix the math. But experiment after experiment, most notably the Michelson-Morley experiment, failed to find any trace of it. The ether didn't exist. Light was moving through a vacuum, and it was doing so at a constant speed, regardless of who was watching. Then came a young patent clerk named Albert Einstein. In 1905, he realized that if the speed of light is truly constant for everyone, then our traditional ideas about space and time must be wrong. If light travels a certain distance in a certain time, and everyone must agree on the speed, then space and time cannot be fixed. They must be flexible, they must warp, stretch, and shrink to protect the constancy of light. To understand this, imagine a light clock. It consists of two mirrors with a single photon bouncing up and down between them. Each bounce is one tick of the clock. Now imagine this clock is moving past you at a very high speed. To the person holding the clock, the photon is just moving up and down. But to you, standing still, The photon has to travel in a zigzag path to keep up with the moving mirrors. A zigzag path is longer than a straight up and down path. But because the speed of light must be the same for both of you, and the photon has to cover a longer distance for you, it must take more time to complete a tick. This is time dilation. Time literally slows down for the person moving. It isn't a trick of the mind or a mechanical failure of the clock. The fabric of time itself is being stretched. But the weirdness doesn't stop with time. As you move faster, the space in front of you also begins to contract. This is known as Lorentz contraction. If you were traveling at 99% of the speed of light, a football field would look like a thin strip to you. The universe shrinks itself to ensure that you never measure light moving at any speed other than the magic number. So why can't we just push through? Why can't we add more energy and finally break the barrier? This is where Einstein's most famous equation comes in, E equals mc squared. This equation tells us that energy and mass are two sides of the same coin. As you accelerate an object, you are giving it kinetic energy. But as you get closer to the speed of light, that energy stops making you go faster and starts making you heavier in terms of relativistic mass. At 10% of the speed of light, your mass only increases by a tiny fraction. But at 90%, your mass is more than doubled. At 99.9%, your mass becomes enormous. To reach 100% of the speed of light, an object with mass would require infinite energy, and its mass would become infinite. You would need the energy of every star in every galaxy just to push a single atom to the speed of light. It is a physical impossibility. But there is a deeper reason, one that goes beyond energy and mass. It is the reason why we should stop calling it the speed of light and start calling it the speed of causality. Imagine the universe as a giant computer simulation. In any simulation, there is a maximum speed at which information can be processed. If you click a mouse, there is a delay before the pixel on the screen changes. The universe has a similar delay. The speed of light is the maximum speed at which one event can influence another. Think about the sun. It is 8 light minutes away from Earth. If the sun were to magically vanish right now, we wouldn't see it happen for 8 minutes. But more importantly, we wouldn't feel the loss of its gravity for 8 minutes either. Gravity, just like light, is limited by this cosmic speed. For those 8 minutes, the Earth would continue to orbit a ghost. We would be living in a reality where the cause has disappeared, but the effect hasn't arrived yet. If the speed of light were infinite, the entire universe would happen at once. There would be no past, no present, and no future. Every cause would result in an instantaneous effect across the entire cosmos. There would be no sequence of events. Evolution couldn't happen. Stars couldn't form. And the very concept of time would have no meaning. The speed of light is the only thing that gives the universe a sense of order. It is the refresh rate of reality. It ensures that the story of the universe unfolds one page at a time, rather than every word being printed on top of each other in a single illegible blot of ink. This brings us to a mind-bending realization. Because the speed of light is finite, we are all living in the past. When you look at the person sitting across from you, you aren't seeing them as they are now. You are seeing them as they were a few nanoseconds ago. When you look at the moon, you are seeing it as it was 1.3 seconds ago. When you look at the stars, you are looking at ghosts. Some of those stars may have exploded and died thousands of years ago, but their light is still traveling toward us, carrying the news of a life that is already over. The night sky is a graveyard of light, a beautiful tapestry of history that we mistake for the present. We often feel frustrated by this limit. We want to travel to distant galaxies. We want to build warp drives and wormholes. We feel like we are trapped in a small corner of the universe, hindered by a speed that is too slow for the vastness of space. But we should be grateful for this limit. It is the protector of our individuality. It is the reason why your actions today don't instantly affect a civilization. The other side of the galaxy, it creates local reality. It allows parts of the universe to grow and change independently of the whole. As we look toward the future, we may find clever ways to cheat the system. We talk about folding space-time or using quantum entanglement. although the latter cannot be used to send information. Faster than light. But even if we never leave our solar system, we have already achieved something miraculous. We are a collection of atoms that originated in the hearts of dying stars, and we have managed to look back at the universe and figure out its deepest rules. We have mapped the walls of our cage, and in doing so, we have discovered that the cage is what makes the garden possible. The speed of light is not an obstacle. It is a signature. It is the fundamental constant that defines the scale of our existence. It tells us that we are part of a grand, orderly progression. It reminds us that every moment is precious because it takes time to happen. The next time you look up at the stars, don't feel small because of the distances. Feel immense because you are the consciousness of the universe, perceiving its own history, one photon at a time. The limit isn't there to stop us. It's there to define us. And that is a truth more beautiful than any science fiction fantasy in the dance between space and time. The speed of light is the rhythm that keeps the music playing. And as long as that light keeps traveling, the story of the universe continues unfolding with a perfect, measured grace that we are finally beginning to understand.